Logarithmic and exponential equations. So we're going to look at solving log equations first. There's a couple different types of questions that we're going to come up. So in the first type, we're going to convert to exponential form, which we've been doing a little bit when we've been finding intercepts on graphs. So here are the steps. You're going to write it as a single logarithm, unless it's already done for you. Convert to exponential form, solve for x or whatever variable is used. Check for extraneous roots. An extraneous root in a logarithmic function is based on the restrictions. Remember, your argument must be greater than 0. So you don't need to verify by substitution. You just need to check that your argument is going to be greater than 0 or a positive number. So let's start with example A. Solve. Step 1, single logarithm. You already have it as a single logarithm. In other words, you see the word log written only once. So now you're ready to put it in an exponential form. So 2 to the 4 is equal to x plus 3 squared. And now you're going to evaluate. So 2 to the 4 is 16. X plus 3, we're going to need to expand that so that we can multiply that through. So we're going to FOIL. So we're going to get x squared plus 3x is going to give me 6x when I combine it, plus 9. Remember, to solve for a quadratic equation, you need to set this equal to 0. So I'm going to move this to the other side. So I'm going to get 0 is equal to, I'm just going to show that I went up here, x squared plus 6x minus 7. And I'm going to factor x plus 7, x minus 1. So x is equal to negative 7 and x is equal to 1. Now, if you were to verify, you could plug this back in and you're going to see. We're not expected to verify necessarily, but you do have to check for extraneous roots. Now, normally you can check for extraneous roots just with you doing your mental math, but I just want to show my work on this particular one. So check for extraneous roots. This isn't a true verification, it's just this step. I just want to see that if this is going to make a positive number. So if I plug in negative 7, negative 7 plus 3 is negative 4. Negative 4 squared is 16. So that's greater than 0. So that means this is one of the solutions. It's not an extraneous root. Do the same for 1. 1 plus 3 squared is 4 squared again. You're going to get 16. That's also greater than 0. So this is fine. I could tell rather quickly, I don't necessarily have to show this, because if I'm squaring a number, it's always going to be positive. So the minute I see a square in my argument, I knew there were no restrictions and that these would work.